In this lesson, we are going to take a look at part 2 to homogeneous differential equations. Now, if you've not watched part 1, try to watch part 1 before you watch this video. So let's take a look at this. Now, if you take a look at the screen, we want to evaluate the homogeneous differential equation y prime is equal to 3s multiply e raised to the power of negative y over s plus y divide s. Now, as you can see, we are given a point. So the first point is 2, while the second point is 0. So meaning the s value is 2, while the y value is 0. So we are going to find the value c because we are given a point. Now, what makes this an homogeneous ordinary differential equation? For an equation to be homogeneous, every term needs to have the same degree. You need to take note of this. Every term needs to have the same degree. Now, if you take a look at this equation, 3s is having a degree of 1. As you can see, y is having a degree of 1, so meaning the degree are same. Now, on the denominator, s is also having a degree of 1, so meaning the degrees are same. So they all have the same degree. So meaning this is an homogeneous ordinary differential equation. So now what we are going to do is I'm going to change y prime to dy over ds. Now, don't get this confusing. Y prime and dy over ds, they are same. It's just that I like to represent my derivative with dy over ds. Okay, so I'm going to change y prime to dy over ds. So this is going to be dy over ds is equal to 3s, then multiply e, then raised to the power of negative y over s, then plus y divided by s. So the first step we are going to take is we are going to cross multiply. Okay, so we need to try to break down this equation. So we are going to cross multiply. So we're going to say cross multiply. If we cross multiply, we are going to have s dy is equal to 3s, then multiply e raised to the power of negative y over s, then plus y, then multiplied by ds. Now, the next step we are going to take is we are going to equate y as vs. So meaning whenever we see y, we are going to replace it with vs. Now, we also need to take the derivative of y, and we are going to use the product rule to take the derivative of y. So this is going to be dy is equal to, so using the product rule, the derivative is going to be s, then multiply dv, then plus v, then multiply ds. By now, you should know how to take derivative using product rule. So the next step we are going to take is we are now going to plug these values inside this equation. Okay, so whenever we see y, we are going to plug vs, and whenever we see dy, we are going to plug this value as well. So this is going to be s, then multiply dy. As you can see, dy is this value, as you can see. So this is going to be s, then multiply s dv plus v ds. Then this is equal to 3s, then multiply e, then raised to the power of negative y over s. And we said y is vs, so this is going to be negative vs because y is vs, negative vs divided by s, then plus y. What is y? Y is vs, so this is vs, then multiply by ds. So we are going to simplify this. So on the left side, it is going to remain the same. So we are going to have s, then multiply s dv plus v ds. Now we're going to simplify the right side. Now what we're going to do is we are going to factor out the common term. Now if you take a look at this, the common term is s because s is common. Okay, so we are going to factor out the value of s outside these parentheses. Okay, so if we do this, we are going to have something like this. So we are going to have s, then multiply by 3e, then raised to the power of negative. Now, if you take a look at this, the s are going to cancel out. As you can see, the s is going to cancel out. Let me write this with red. So the s are going to cancel out. So we are left with v. Okay, so this is going to be negative v, then plus v. Okay, because we factor out s, then we have to include the s. Now the next step we are going to take is we are going to divide both sides by s. As you can see, we are having s on the left, we are also having s on the right. So we need to cancel out this s. And how can we do this? We are going to divide both sides by s. So if we divide both sides by s, we are going to cancel out the s. Okay, so this is going to be s dv, then plus v ds is equal to 3e, then raised to the power of negative v plus v, okay, plus v ds. So we need to include the s. Okay, so as you can see, we no longer have s because they cancel out. So let me indicate this using a red marker. So the s, they cancel out. Now, what we're going to do is the left side is going to remain the same. Okay, so let me quickly write this. So this is s dv plus v ds is equal to. Now, on the right side, we are going to multiply the s with everything inside these parentheses. Okay, so if we do this, this is going to be 3 multiply e raised to the power of negative v, then multiply ds, then plus v ds. So the next step we are going to take is we are going to subtract both sides by v ds. Okay, so we need to subtract both sides by v ds. As you can see, we are having v ds on the left, we are also having v ds on the right. So we need to cancel out this v ds. And how can we do this? We are going to subtract both sides by v ds. So if we subtract both sides by v ds, we are going to have s dv is equal to 3e, then raised to the power of negative v ds. Now, as you can see, this is what we have. So what we are going to do next is we need to separate the variables. Okay, so we need to separate these variables. And how can we separate these variables? We are going to say divide both sides by s multiply 3e raised to the power of negative v. So this is the next step. We are going to say divide both sides by s, then multiply 3e raised to the power of negative v. Okay, so let me continue here. So if we divide both sides by s multiply 3e raised to the power of negative v, so this is s dv, then divided by s multiply 3e raised to the power of negative v is equal to 3e raised to the power of negative v ds divided by s multiply 3e raised to the power of negative v. So on the left side, the s are going to cancel out. So s is going to cancel s. Then on the right side, 3e raised to the power of negative v is going to cancel out 3e raised to the power of negative v. Okay, so we are now going to have on the left side, we are going to have dv over 3e raised to the power of negative v. So we can write this as 1 over 3e then raised to the power of negative v dv is equals to, then on the right side we are going to have the s over s, and we can also write this as 1 over s then multiply ds. As you can see, we now have the variables separate. Okay, if you take a look at the left side, we only have the v variables, and if you take a look at the right side, we only have the s variables. Okay, so now the next step we are going to take is we are now going to simplify this further. Okay, so if we simplify this further, on the left side, we are going to have something like this: e raised to the power of v, then divided by 3dv. So what I did is I took the reciprocal of this. So if you take the reciprocal of this, e raised to the power of v is going to be on the numerator, while 3 is going to be on the denominator. Okay, so this is equal to 1 over s ds. Now the next step we are going to take is we are going to integrate both sides. Okay, so this is the next step we are going to take. We are going to integrate both sides. Okay, so we are going to take the integral on the left. We are also going to take the integral on the right. Now, because we are having a constant on the denominator, we are going to take this constant outside. Okay, so we are going to take it outside the integral. So this is going to be 1 over 3. Then we need to take the integral of e raised to the power of v. The integral of e raised to the power of v is e raised to the power of v. So this is going to be e raised to the power of v. Then it's equal to, then what is the integral of 1 over s? The integral of 1 over s is ln of the absolute value of s, or ln of s. Okay, so this is ln of s. Then plus c. We need to include plus c because we are dealing with indefinite integral. Now, if you remember, we said y is equal to vs. Now, we are going to solve for v. So if y is equal to vs, v is going to be equal to y over s. So whenever you see v, you are going to plug y over s. So this is going to be 1 over 3, then multiply e raised to the power of y over s. Okay, so we replace v with y over s. Then this is equal to ln of s, then plus c. Okay, now what we're going to do is we need to get rid of this fraction. And how can we do this? We are going to multiply both sides by 3. So we're going to multiply the left side by 3. We're also going to multiply the right side by 3. So if we do this, we are going to have e raised to the power of y over 3, sorry, not 3, y over s is equal to 3 multiply ln of s, then plus 3c, because we multiply both sides with 3. Now, we can also write this as e raised to the power of y over s is equal to, now 3 multiply ln of s can also be written as ln of s raised to the power of 3. Okay, then plus 3c is a constant. So if 3c is a constant, meaning we can also write 3c as c, because c is also a constant, so they are same. Okay, now this is the general solution to the differential equation. But because we were given a point, as you can see, we were given a point 2, 0, we can't stop here. We need to find the value c in order for us to have the particular solution to the differential equation. So 2 is the s value, while 0 is the y value. So whenever we see 2, whenever we see s, we are going to replace it with 2, and whenever we see 0, and whenever we see y, we are going to replace it with 0. Okay, so this is going to be e raised to the power of 0 over 2 is equals to ln of 2 raised to the power of 3, then plus c. So 0 over 2 is going to give us 0, then e raised to the power of 0 is going to give us 1. So this is 1 is equals to ln of 2 raised to the power of 3 is 2.1. We can also write it as 2. So this is 2, then plus c. So if I have plus c, sorry for that, plus c. So if we evaluate this, we are going to get c is equal to negative 1. So what we need to do, we just need to plug negative 1 in place of c. So this is going to be e raised to the power of y over s is equal to ln of s raised to the power of 3. Then what is c? C is minus 1, then minus 1. So this is the particular solution to the differential equation. So if you are given a point, you need to find the value c. So this is what we know as the particular solution to the differential equation. But if you are not given a point, you need to stop here. You don't need to find the value c, because you are finding the general solution to the differential equation. So this is how we can find the particular solution to the homogeneous differential equation. So this is the end of this lesson. Now, if you are new to this channel, or maybe you have been watching this channel for a long time and you've not subscribed to the channel, please consider subscribing to this channel, because I make videos on mathematics and civil engineering courses. So if you are looking for this kind of content, consider subscribing to the channel by clicking the red subscribe button under this video and click the bell notification icon below, so that whenever I upload a new video, you will be the first to get notification. And also, if you enjoyed this video, don't forget to give this video a thumbs up, and you can share this video with your friend as well. So this is where we are going to call it. I will see you all in my next video. So stay safe, everyone. God bless you all.